Hi, my name's Andy Klemenko. I'm a senior solutions engineer at StackRox. Thanks for joining us today for my talk on labels, labels, labels. Obviously, you can reach me at all the socials. Before we get started, I'd like to point you to my GitHub repo. You can go to andyc.info/dc20, and it'll take you to my GitHub page where I've got all of this documentation. I've got the keynote file there, YAMLs, Docker files, compose files, all that good stuff. If you want to follow along, great. If not, go back and review later. It's kind of fun. So let me tell you a little bit about myself. I am a former DoD contractor. This is my 7th DockerCon. I had the pleasure to speak at a few of them, one even in Europe. I was even a Docker employee for quite a number of years, providing solutions to the federal government and customers around containers and all things Docker. So, been doing this a little while. One of the things that I always found interesting was the lack of understanding around labels. So why labels, right? Well, as a former DoD contractor, I had built out a large registry, and the question I constantly got was, where did this image come from? How did you get it? What's in it? Where did it come from? How did it get here? And one of the things we did to kind of alleviate some of those questions was we established a baseline set of labels. Labels really are designed to provide as much metadata around the image as possible. I ask everyone in attendance, when was the last time you pulled an image and had 100% confidence you knew what was inside it, where it was built, how it was built, when it was built? You probably didn't, right? The last thing we obviously want is a container fire, like our image on the screen. And one kind of interesting way we can kind of prevent that is through the use of labels. We can use labels to address security, address some of the simplicity on how to run these images. So think of it kind of like self-documenting. Think of it also as like an audit trail, image provenance, things like that. These are some interesting concepts that we can definitely mandate as we move forward. What is a label, right? Specifically, what is the schema? It's just a key value, right? It's any key and pretty much any value. What if we could dump in all kinds of information? What if we could encode things and store it in there? And I've got a fun little demo to show you about that. But let's start off with some of the simple keys, right? Author, date, description, version, some of the basic information around the image. That would be pretty useful, right? What about specific labels for CI? What about where's the version control? Where's the source? Right? Whether it's Git, whether it's GitLab, whether it's GitHub, whether it's Gitosis, right? Even SVN, who cares? Where are the source files that built? Where's the Docker file that built this image? What's the commit number? That might be interesting in terms of tracking the resulting image to a person or to a commit, hopefully then to a person. How is it built? What if you wanted to play with it and do a git clone of the repo and then build the Docker file on your own? Having a label specifically dedicated on how to build this image might be interesting for development work. Where it was built, and obviously what build number, right? These kind of all not only talk about continuous integration, CI, but also start to talk about security. Specifically what server built it, the version control number, the version number, the commit number. Again, how it was built. What's the specific build number? What was that job number in, say, Jenkins or GitLab? What if we could take it a step further? What if we could actually apply policy enforcement in the build pipeline, looking specifically for some of these specific labels? I've got a good example of in my demo of a policy enforcement. So let's look at some sample labels. Now, originally, this idea came out of label-schema.org, And then it was modified to open containers, org.opencontainers.image. There is a link in my GitHub page that links to the full reference. But these are some of the labels that I like to use just as kind of like a standardization. So obviously authors, an email address. So now the image is attributable to a person. That's always kind of good for security and reliability. Where's the source? Where's the version control that has the source, that the Docker file and all the assets? How it was built, build number, build server, the commit we talked about, when it was created, a simple description. A fun one I like adding in is the health Z endpoint. Now, obviously, the health check directive should be in the Docker file, but if you've got other systems that want to ping your applications, why not declare it and make it queryable? Image version, obviously that's a simple declarative. And then a title. And then I've got the two fun ones. Remember I talked about what if we could encode some fun things? Hypothetically, what if we could encode the compose file of how to build the stack in the first image itself? And conversely, the Kubernetes. Well, actually, you can. And I have a demo to show you how to kind of take advantage of that. So how do we create labels? And really, creating labels is a function of build time. Okay? You can't really add labels to an image after the fact. The way you do add labels is either through the Docker file, which I'm a big fan of because it's declarative, it's in version control, it's kind of irrefutable, especially if you're tracking that commit number in a label. You can extend it from being a static kind of declaration to more a dynamic with build arguments. And I'll show you in a little while how you can use a build argument at build time to pass in that variable. And then obviously if you did it by hand, you could do a Docker build -- label key equals value. I'm not a big fan of the third one. I love the first one and obviously the second one. Being dynamic, we can take advantage of some of the variables coming out of version control, or I should say some of the variables coming out of our CI system. And that way it self-documents effectively at build time, which is kind of cool. How do we view labels? Well, there's two major ways to view labels. The first one is obviously a Docker pull and Docker inspect. You can pull the image locally, you can inspect it, you can obviously, it's going to output as JSON, so you're going to use something like JQ to crack it open and look at the individual labels. Another one which I found recently was Skopeo from Red Hat. This allows you to actually query the registry server, so you don't even have to pull the image initially. This could be really useful if you're on a really small development workstation and you're trying to talk to a Kubernetes cluster and wanting to deploy apps kind of in a very simple manner. Okay. And this was that use case, right? Using Kubernetes, the Kubernetes YAML. One of the interesting things about this is that you can base64 encode almost anything, push it in as text into a label, and then base64 decode it, and then use it. So in this case, in my demo, I'll show you how we can actually use the kubectl apply, piped from the base64 decode, from the label itself, from Skopeo talking to the registry. And what's interesting about this kind of technique is you don't need to store Helm charts. You don't need to learn another language for your declarative automation, right? You don't need all this extra levels of abstraction. Inherently, if you use it as a label with a kubectl apply, it's just built in. It's kind of like the KISS approach to a certain extent. It does require some encoding when you actually build the image, but to me, it doesn't seem that hard. Okay, let's take a look at a demo. And what I'm going to do for my demo before we actually get started is here's my repo. Let me actually go to the actual full repo. So here's the repo, right? And I've got my Jenkins pipeline because I'm using Jenkins for this demo. And in my demo Flask, I've got the Docker file, I've got my Compose and my Kubernetes YAML. So let's take a look at the Docker file, right? So it's a simple Alpine image. The arg statements are the build time arguments that are passed in. Label, so again, I'm using the org.opencontainers.image.blank for most of them. There's a typo there. Let's see if you can find it. I'll show you it later. My source, build date, build number, commit. Build number and git commit are derived from the Jenkins itself, which is nice. I don't, I can just take advantage of existing URLs. I don't have to create anything crazy. And again, I've got my actual Docker build command. Now this is just a label on how to build it. And then here's my simple Python, APK upgrade, remove the package manager, kind of some security stuff, health check, and Python 3. Okay. Let's take a look at the Jenkins pipeline real quick. So here is my Jenkins pipeline, and I have four stages. I have build. And here in build, what I do is I actually do the git clone, and then I do my Docker build. From there, I actually tell the Jenkins StackRox plugin, so that's what I'm using for my security scanning, to go ahead and scan. Basically, I'm staging it to scan the image. I'm pushing it to Hub, okay, where I can see basically I'm pushing the image up to Hub such that my StackRox security scanner can go ahead and scan the image. I'm kicking off the scan itself. And then if everything's successful, I'm pushing it to prod. Now what I'm doing is I'm just using the same image with two tags, pre-prod and prod. This is not exactly ideal. In your environment, you probably want to use separate registries, a non-prod and a production registry. But for demonstrational purposes, I think this is okay. So let's go over to my Jenkins. And I've got a deliberate failure. And I'll show you why. There's a reason for that. And let's go down. Let's look at so I have a StackRox report. Let's look at my report. And it says image required image label, alert, right? Request that the maintainer add the required label to the image. So we're missing a label. Okay. One of the things we can do is let's flip over and let's look at Scopio. Right. And what I'm going to do this the easy way. So instead of looking at org zdocker open containers.image.authors. Okay, see where it says build signature? That was the typo. We didn't actually pass in. So if we go back to our repo, we didn't pass in the build time argument. We just passed in the word. So let's fix that real quick. Let's vim the Docker file. And let's go ahead and put our $sign in there. First day with the fingers, you gotta love it. And let's go ahead and commit that. Okay, so now that that's committed, we can go back to Jenkins and we can actually do another build. And there's number 12. And as you can see, I've been playing with this for a little bit today. And while that's running, come on. We can go ahead and look at the console output. Okay, so there's our image. And again, look at all the build arguments that we're passing into the build statement. So we're passing in the date, and the date gets derived on the command line with the build argument. So there's the base64 encoded of the compose file. Here's the base64 encoding of the Kubernetes YAML. We do the build. And then let's go down to the bottom. Layer exists and successful. So here's where we can see no system policy violations were found, marking StackRox image security plugin build step as successful. Okay. So we're actually able to do policy enforcement that image exists, that label, exists in the image. And again, we can look at the security report, and there's no policy violations and no vulnerabilities. So that's pretty good for security, right? We can now enforce and mandate use of certain labels within our images. And let's flip back over to Scopio, and let's go ahead and look at it. So we're looking at the prod version again, and there's my email address. And that validated, that was valid for that policy. So that's kind of cool. Now, let's take it a step further. What if, let's go ahead and take a look at all of the image, all the labels for a second. Let me remove the -r and make it pretty. Okay. So we have all of our image labels. Again, authors, build, commit number. Look at the commit number. It was built today, build number 12. We saw that, right? Delete build 12. So that's kind of cool. Dynamic labels. Name, health Z, right? But what we're looking for is we're going to look at the org ZDoc or K8s label. So let's go look at the label real quick. Okay, well, that doesn't really help us because it's encoded, but let's base 64-D. Let's decode it. And I need to put the -r in there because it doesn't like, there we go. So there's my Kubernetes YAML. So why can't we simply kubectl apply -f? Let's just apply it from standard in. So now we've actually used that label from the image that we've queried with Skopeo from a remote registry to deploy locally to our Kubernetes cluster. So let's go ahead and look. Everything's up and running. Perfect. So what does that look like, right? So luckily, I'm using traffic for ingress because I love it. And I've got an object in my Kubernetes YAML called flask.docker.life. So that's my ingress object for traffic. I can go to flask.docker.life and I can hit refresh. Obviously, I'm not a very good web designer because the background image and the text. We can go ahead and refresh it a couple times. We've got Redis storing a hit counter. We can see that our server name is round robining. Okay. That's kind of cool. So let's kind of recap a little bit about my demo environment. So my demo environment, I'm using DigitalOcean, Ubuntu 19.10 VMs. I'm using K3s instead of full Kubernetes, either full Rancher, full OpenShift, or Docker Enterprise. I think K3s has some really interesting advantages on the development side, and it's kind of intended for IoT, but it works really well, and it deploys super easy. I'm using Traefik for ingress. I love Traefik. I may or may not be a Traefik ambassador. I'm using Jenkins for CI, and I'm using StackRox for image scanning and policy enforcement. One of the things to think about, though, especially in terms of labels, is none of this demo stack is required. You can be in any cloud, you can be in CentOS, you can be in any Kubernetes, you can even be in Swarm if you wanted to with Docker Compose. Any ingress, any CI system, Jenkins, Circle, GitLab, it doesn't matter. And pretty much any scanning. One of the things that I think is kind of nice about at least StackRox is that we do a lot more than just image scanning, right, with the policy enforcement, things like that. And I guess that's kind of a shameless plug. But again, any of this stack is completely replaceable with any comparative product in that category. So I'd like to, again, point you guys to the andc.info DC20. That's take you right to the GitHub repo. You can reach out to me at any of the socials at Klemenko or Andy@stackrox.com. And thank you for attending. I hope you learned something fun about labels, and hopefully you guys can standardize labels in your organization and really kind of take your images and the image provenance to a new level. Thanks for watching.